domain of these, is that right?
Yes.
Okay, so you've got to factor the bottom. That's
Mhm.
so actually g of x, we'll start with g of x. That's the easier one here.
Right.
You set the bottom not equal to 0, believe it or not, because it's excluded. Whatever the bottom is what it cannot be. On a number line, you go to 4 and you're like, okay, it's excluded, but it can be everything else. So in interval notation, that's negative infinity to 4.
To 4.
And I don't remember if I saw union or not, but union to 4 to infinity.
Yeah, we have the union symbol.
Okay, so it's excluded. It's everything but 4.
Okay.
Now the other one takes a bit more effort. You do have to factor the bottom. So you have to find two numbers that multiply to 2 and add to 3, x plus 1.
And then
And even though there's like there is something that you'll do later on in this course with this x plus 1, you really only look at the bottom.
The denominator is above, right?
So this one you set x plus 2 not equal to 0, x plus 1 not equal to 0, x cannot be negative 2, x cannot be negative 1. Again, you go to a number line, make sure you get the numbers in the right place relative to each other. Open circles because they're excluded, but it can be everything else. It can be everything from negative infinity to negative 2, negative 2 to negative 1 to positive infinity. So you start writing those intervals, negative infinity to negative 2, union negative 2 to negative 1, union negative 1 to infinity.
Okay. Okay, yeah, I remember we did a little bit of this a few lessons ago.
Yes.
So let me just type these in.
And please double check them. They're, it's easy to get a little thing wrong and it's all off.
Yeah. I'm gonna do the bottom one first. Actually, there isn't a union symbol. Oh wait, I see it. I found it. That's my fault. Positive. And then the first one, it's not letting me type x plus 1 for the numerator.
Oh, you don't. So sorry. Just to be clear, the answer is the part in the union part.
The union, right? Okay.
So nothing to the I don't know. This is the answer to A, and this is the answer to B. That was just like a side work step to be able to.
Okay. Okay, got it. Okay, I'll share my screen again. This is the next one. So
yeah. So how's your factoring? Like, how comfortable are you with?
Yeah, I'm good at factoring. Yeah.
Okay.
So the first one.
Yeah, I grabbed it. I'm gonna share my screen, but you're basically just factoring the bottom. Factoring
the bottom, right?
Ignore
so
the
yeah,
top
the bottom one is, we can start with the bottom one because that's x plus 3 and then x minus 3.
That's right. And you said both of those not equal to 0. Those become your excluded values.
Which is negative 3 and positive 3.
Right. So it's everything on the number line except those.
So it'd be negative infinity, comma, negative 3 with the parentheses.
That's right.
And then union, and then the next one would be the bracket, and that would be
parentheses. No brackets. Yeah, no brackets, because you're not allowed to use that point, and the parentheses is excluding.
So I guess I'll start typing it.
Yeah, I'll take a look here.
Yeah, so let's be negative infinity to negative 3 union, and then the next one would be parentheses positive 3.
Yes, minus 3 to positive 3, because you're including all. Sorry. The minus infinity is always a parentheses.
Over here.
Yes. Yes. And then
so why was it a bracket in the first one?
It wasn't.
Okay.
Hopefully.
Yeah,
maybe
I did type it incorrectly, but
no, it is parentheses in all of these.
Okay.
Now it's
And
from
then-
-3 to 3
Mhm.
there. That's the gap between them,
Mhm.
union
And then
3 to infinity.
like this.
Yes.
Okay. And then the first one is x plus 1 and then x minus 1.
That one is it's called a perfect square trinomial. You're looking for two numbers that multiply to 1 but add up to -2.
Oh, to 1 and minus. Oh, that's just sorry, 1 and 1.
Yes. So 1 is the only excluded. It becomes x minus 1 squared.
Mhm.
So 1 is the only excluded value on that
Okay.
one. So
So it would be parentheses again.
yes. Parentheses for all these.
And then negative infinity and then 1,
Yes.
like so. And then this is the final answer because
Nope. You got to keep going because you're that's everything up to 1.
Mhm.
So you're
Oh,
now
so
want to say
union
union 1 to infinity.
1 to positive infinity, yeah.
Yes.
Oh, okay. That's the final answer because you only have the negative and positive.
Yes.
Okay. Okay, gotcha. Okay, so I guess.
So let's talk about the top one
Mhm.
because it's an exception. X
Right.
squared plus 16 is not factorable. It kind of looks like the difference of squares, but it's a sum of squares,
Mhm.
and those are considered prime. So there's no way to factor the bottom there. So there's no exclusions.
This one.
The x squared plus 16.
16.
So it's like it kind of reminds you of that one we did earlier. It was like I think it was x squared minus 9, but because it's plus 16, it's
There's
not
no.
factored. There's no sum of
Oh,
squares. So that has no restrictions. So it's
so
everything. It's minus infinity to infinity.
okay.
Yeah, if you want me to share my screen, I mean, I can explain this more. I'm just
Yeah. Could you expand
of
on it
course,
a little bit
yes,
more?
yes. All right. Okay, so the idea with this bottom one here is if you set x squared plus 16 equal to 0 and you subtract 16 from both sides, you're squaring a number. Squaring always returns a positive. How can it ever be negative?
Yeah,
It can't be.
root, right?
And then graphically, x squared plus 16 looks like this. Does it ever cross the x-axis?
No.
No. So this never equals 0.
Okay.
The bottom never equals 0. And that's the whole point of what we're
Right.
doing. We're trying to figure out where's the bottom 0 because that's the excluded value. So your number line goes from minus infinity to infinity. Well, there's no exclusion points, so it's everything.
Everything. Okay. So it's
So
just
parentheses minus infinity to infinity.
Okay, that makes more sense. The visual.
Okay, so we can do the next one now whenever you're ready.
Yeah.
You're trying to find two numbers that multiply to minus 72 but add up to positive 1. Anything come to mind there for that?
It's 8 and 9, but we have negative 8.
That's right. So it becomes x minus 8, x plus 9.
9.
And again, these cannot be 0. So you set them not equal to 0. X minus 8 not equal to 0. X plus 9 not equal to 0. So x cannot be 8. X cannot be negative 9.
Right.
So on your number line always goes from minus infinity to infinity. And you throw in the excluded points. And then it's everything in between. So in terms of like when you're putting into web, Alex there, each of these regions corresponds to something. So it's like minus infinity, minus 9, minus 9 to 8, 8 to infinity. Each of
So
those
it's like all the gaps in between like the timeline.
Yes. Yeah, exactly.
Yeah.
That's good.
Okay. Type that in. positive. Okay. I think for future reference, I'll probably just like draw the timeline and that'll help me know like the gaps.
Yeah.
Between the unions. Okay. Okay. Okay, let me find something else to work on. Let's see. Kind of grab like another word problem or something. Okay, I'll share my screen. Yeah, I guess we have more of like the distance and rate and then against the wind and with the
Yeah,
wind.
let's do them. We'll make the table again. And
okay.
All right, let me grab a snip. All right, so we got a plane cruising speed of 100 miles per hour when there's no wind. And at this speed, the plane flew 600 miles with the wind. The same amount of time it flew 400 miles against the wind. So we've got width and against, distance, rate,
and
time.
Okay.
We just fill in whatever we think we have. So plane has a cruising speed of 100 miles per hour when there is no wind. So at this speed, the plane flew 600 miles. So that's your distance. Now with the wind means 100 plus W. I use W for wind. You could use another. Yeah. Because it helps
W
you.
words. Yeah.
Okay. And the time it took, it doesn't say, so we'll just call it T for the moment. But it's the same amount of time to go against the wind. Now to go 400 miles and 100, it's now hurting minus W.
Minus W.
Yes.
Okay, gotcha.
And the overarching equation here is distance equals rate times time. So 600 equals parentheses 100 plus W times T. 400 equals 100 minus W times T.
Okay.
And so you effectively have two equations and two unknowns. Okay. Now before we would just divide by the time because it was a number. We can't do that here. We're gonna actually, we have to solve both of these for T, which means you're going to divide both sides by the 100 plus W. So or minus, I'll show you that down here. So you divide both sides by this. So T equals 600 over 100 plus W. Same thing here. T equals 400 over 100 minus W. And so now you set them equal. Same time, set them equal. 600 over 100 plus W equals 400 over 100 minus W. And this is where you cross multiply.
Oh, okay. And then we'll distribute that.
Yes. So 600 times 100 minus W. 400 times 100 plus W. 6,000 minus 600 W. 4,000 plus 400 W. So move the 4,000. Add the 600 W. And you get 2,000 equals 1,000 W. So W equals 2.
And that is the speed, or what did it say?
That's the variable. Yeah, that's the speed of the wind. Yeah.
So 2 miles an hour.
Yeah.
Oh, okay.
I guess that's reasonable. I don't really know. But maybe you can try it. I mean, the first one we get at least
let me plug it in. Okay, it said your answer is incorrect.
Yeah, so there's a sign error, there's a multiplication error here. Yeah, sorry about that. This I knew that seemed right. So one thing's like I don't like here is I would have gotten rid of the zeros in the 600 and the 400 because you're dividing both by 100.
Okay.
And
Oh, right, right.
that makes this
Mhm.
I'm prone to errors here. 600 minus 6W equals 400 plus 4W. So this is much better. So this is going to
Mhm.
be 200 equals 10W, W equals 20.
Yeah. Oh, okay, that makes so much sense. Yeah, that's correct. Okay, perfect. Okay, I'll share again.
Yep, let's do another one. They're let's see what variation they give you this time.
Yeah. We'll play this cruise. Set the table with.
So it looks like we got a with and against again.
Right.
With and against. We got a distance, a rate, and a time. Okay, so this time though, it's going a little bit faster. So W, the variable is almost always the thing that it's asking for.
Yeah.
So we're going 300. Nope, I'm sorry. It's going 600 miles, 300 plus W.
Plus W with.
In the same amount of time that it took to go 400 miles, 300 minus W. So this is the exact same setup as the last problem.
Okay.
So you want to try solving this for me?
Yeah, I can attempt it.
All right.
Okay, and I got 30. Oh, yeah.
Hang on. This doesn't look right. There's something. It
I think, oh wait, I think I did somewhere. Isn't or oh.
I'm sorry. It's 6. Yeah. So this is why it's 600 here, and then it is 60.
Okay, to subtract from.
Yeah, I didn't show the step, and that's why it was made an error. I just checked that with another tool, so I'm confident that this is correct here.
Yeah. Yeah, that is correct. Okay, okay, I'll share my screen again, but I can attempt it.
Sure, if it's the same, it may be a variation, so just
because sometimes I'm sure, yeah, I think this one's already.
And then on the test or the quiz, you probably only get one of these if you get one.
Yeah, I think it'll just be one.
Won't be 3 in a row.
So this one is. So now we're trying to find the rate swam with no current.
Yeah, this one's slightly different. It's still doable. It's the same setup, but it it looks different at first glance. So there's like with the current and then against.
Right.
And then there's the distance, the rate, and the time. So it says Caitlin swam 4 kilometers.
That's the distance.
Against, you got it in the right place. In the same amount of time, it took her to swim 16 kilometers with the current. The rate of the current was 3 kilometers per hour. So when it's her rate, I like to use R. So width is R plus 3. And then R minus 3.
Yeah.
And now it truly is just like the last one.
The same setup. Yeah. Okay.
Yeah, so give it a try.
Wait, hold on. I got stuck on a step.
Okay. How are you doing up to where I'm at?
Yeah, I got stuck on, so after the t equals 16, we set it up like the cross, I don't know how to put it.
Cross multiply. Yeah, so
Yeah.
you get 16 times R minus 3 equals 4 times R plus 3. Is that okay? Is that
Yeah.
so 16R minus 48 equals 4R plus 12. And then this time I will show it because I didn't last time. Oops, that's the wrong way. I want to go the other way with that. Add 48. So you get 12R. 12R equals 60. R equals 5.
Yep. Okay, perfect. Okay, these were simple. The table really helps.
Yeah. It's I wish they just have you set it up. That's almost like, that's a good enough, but
right. Okay, perfect. Okay, let me find something else. Okay, we can do more like, I guess, interval notation. Something like this.
okay. Yeah, this one it's related to what we were just doing with an added like extra little bit of it. So let me grab the whole thing. All right. So this one has kind of 2 parts to do. You have to look about the top and the bottom. So we'll first look at the bottom here. So minus 10 plus X cannot be 0. You cannot divide by 0. That's really bad. So you add 10 to both sides and you find that X cannot be 10. So on your first number line here, minus infinity to infinity, 10's right there. It's everything but 10. Is that clear?
Yes.
Okay. Now for the other one, which I'll do in green here, with the root, you have to set the root greater, the part inside the root greater than or equal to 0.
Okay.
So just the part inside the root. Okay.
Right.
So now it's x greater than or equal to negative 9.
-9.
Okay, and this is where when you draw your number lines underneath, the relative position matters. So -9 is over here somewhere relative to 10.
Right.
And it's everything to the right of that.
Okay.
Okay, so now this is the hard part is you have to get the place where they're both true. So like basically kind of an overlap. So like they're both true starting at 9. So that's a bracket. But at 10, are they both true?
No.
So 10 is a stopping point.
Okay.
Union 10, and you keep going to the right.
Okay. I guess
So they have to both be true.
both be true. Okay.
It's kind of like, okay, it's like you're trying to figure out a schedule with someone. And they're like, oh, I'm free every day except the 10th. And you're like, I'm free starting on the -9th. Well, you can't meet on the 10th because they're not free.
Free. Okay. And it's an open circle because
It cannot be, you cannot be 10 on the bottom because then you're dividing by 0.
and then it's a closed circle because x is everything greater than 9, -9.
Or equal to.
Or equal to.
Yeah.
Okay.
Because with roots, you can take the square root of a negative.
So these written together will be one equation.
This is the answer to enter, just to be clear.
It's one.
But you have to assimilate. It's really very much a scheduling problem. It's like someone's available everywhere except the 10th.
Okay.
And you're like, look, I'm only available starting at the -9th. So the 10th is out, but everything else is good.
Okay. Yeah, I think I'll just as we go, maybe I'll start getting. Okay, I'll share my screen again. So this is the next one.
This one is easier by comparison. Oh man, like sometimes I don't understand why Alex doesn't give you the easy ones to start.
Yeah. It's very flip-floppy.
All right, let me share my screen. Okay, so the -8 on top is not, doesn't matter. Just you can ignore that.
Ignore it, right?
But the bottom here has got something kind of new. There's a couple things going on. Like the bottom cannot be 0, right? It cannot equal 0. The inside part has to be greater than or equal to 0. The inside part has to be greater than or equal to 0 because you can't take the square root of a negative.
Okay, right.
Okay, so you add 8 to both sides and you get x is greater than or equal to 8. But what happens at 8? What happens when you take the square root of 8 minus 8?
Square root of 8 minus 8. That's 0.
0. And the square root of 0 is 0. That's not allowed. So you have to exclude this to be just greater than 8.
Greater. Okay. I'm like a little confused, but
I know. So this is like, it's like, well, there's two pieces here. The first is that the square root has to be greater than or equal to 0. But the second part is that the bottom of fraction cannot equal 0. So like the first thing you found is that x minus 8 is greater than or equal to 0. And you're like, okay, x is greater than or equal to 8. But at 8, when x is 8, the square root of 8 minus 8 is 1 over 0.
It's just 0. Oh, okay.
And that's why you're like, oh, it can't be 8 either. So you have to make it x greater than 8.
Okay. This is okay. That makes sense.
So on a number line, you're starting at 8, but it can't be 8. But it's everything to the right of 8. So that's parentheses 8 infinity.
Okay. Okay, I'm kind of getting it. Okay. Okay, I'll just do the next one. This one's different.
All right. Grab a snip of this. It's similar to the last one, just a little wrinkle, little distinction. Let me share this. Okay, so so a lot of times in math, there's what's called a rewrite step. And the property here is the square root of A over B is the square root of A over the square root of B.
Right.
So how that applies here is it's the square root of 7 over the square root of x plus 10.
Right.
The top doesn't matter. It's a number, whatever, you don't care. You do have to look at the bottom though. And again, there's two issues with the bottom. The first is that x plus 10 has to be greater than or equal to 0. Like you have to take the square root of a positive number or 0.
Okay.
So you subtract 10 from both sides.
Wait, so why can't 0 be the greater number then? Like,
well, are you asking why it's greater than or equal to 0 or why it's not just greater than 0?
Why it's greater than or equal to 0.
So the domain, it comes from the domain of the square root function. The part under the root is always greater than or equal to 0.
Okay.
But when you put it underneath, you now set it just greater than 0.
Okay.
Because you can't divide by 0. You like at 0, it's bad.
Right. Because it's
down
just
here.
itself.
And that's what I was getting to here is when you put negative 10 in, negative 10 plus 10 is
it's just 0.
And that's bad because you can't divide by 0.
0. Okay. That makes sense.
That's why you're like, oh, it's just greater than negative 10.
10.
Okay.
Okay.
So there's negative 10 on your number line, open circle because of the greater than, but it's everything to the right.
Everything to the right. So that's parentheses negative infinity. Wait, no, it's negative 10, comma, positive infinity.
Yes, let me write it out.
Yeah, okay, that's how I wrote it down. Okay, that made a little bit more sense. Okay, let's see what else I can pick. Okay, I guess I'll do this one. I attempted to do it, but then I couldn't figure out how to set it up, so I don't have like a previous example, or I can press explanation if you need it.
Sorry, I was muted. Yeah, I grabbed a snip here. This is a mixture problem, so we're going to use a table.
Okay.
Let me try that out here. All right, the size, two versions of a popular song. The size of the standard version is 2.6, high quality is 4.4. Here's the high quality version was downloaded twice as often as the standard version. Sorry, this may not be, I'm sorry, I was reading it wrong, but it's that these are kind of mixture problems, but they're writing the system of equation problems.
Right.
So the first equation here, it really comes from the total. Okay, so it's saying 2.6x because of the standard version is 2.6. The high quality version is 4.4. Y equals 2622. That's kind of your mixture. It's like it's like the quantity times the amount. Thing. Now,
but then it also says in the equation the high quality version was downloaded twice as often. So is there another variable?
Yes. No. This is x and this is y. X is the standard, y is the high quality.
The high quality one.
And then the question that often gets raised, well, is it this one or is it this one?
Y equals 2x.
Yeah, and if you're ever unsure, you can make a table real quick of like standard and high and be like, okay, if there were 8 high qualities, that means there was 4 standards. And which equation says that? It's the one you got there.
Could you repeat that?
Well, so the like you know that this equation is correct, but it satisfies like a numerical example, which is you just pick a number like 4 standard versions, and there were supposed to be twice as many high quality as standards. That would be 8.
Such as 8, such as times 2. Yeah.
And does that work with your equation? Yes.
Yes. Yeah.
Okay. So now that that's done, you're going to use substitution here. You're going to put the 2x
into the y.
Yes. So 2.6x, 4.4 times 2x, 2622.
Okay. And then distribute.
So that's, let's see here, 11.4x equals 2622. Then you're going to divide.
And that's 230.
And what you have to be really careful of is that actually what it's asking for? Like, is that the standard version? And it is. In this problem, it is. But if it was asking for the high quality, you'd have to manipulate that number.
Okay.
But it looks like it is 230.
230. Yeah.
Yeah.
Okay. But yeah, that was correct. I'll share my screen again. Okay. Yeah, I can attempt to do this one.
Sure. See if you can set up the equations. I'm going to grab a snip
Okay.
and I'll share my screen here. But the setup is really the important part.
Right.
Are you using A or B, X or Y?
I did X and Y.
Okay.
So I have I wrote it like that, and
Good.
then Y is going to equal 3x.
That's right. Okay. So do you want to try solving this?
Process. Yeah. And I got 37.
Yes, that is correct.
Okay, I'll share my screen again, but yeah, I can attempt this one as well. So the first equation I have, but I'm kind of stuck on how to, because we have the total amount of tickets, but we don't know.
So they're split between which 2 groups for the tickets?
The adults and children's.
And so call X your child and Y your adults.
Adults, yeah.
And so they add up to that total there.
Title, which I wrote, yeah, and then the second equation, so that would be how many adult tickets, y equals. Like we don't, wait, well, there's two different types of tickets, so would it be
So-
y equals 2x?
No, they add up together. The total tickets is 168. So that together, here, I'll share my screen. Together,
So x plus I equals 168, yeah.
yes, that's like your second equation.
Second, yeah.
Your money equation, or really your mixture equation. That's this one up here. The mixture equation is 560 for a child's ticket, 9 for an adult's ticket, and that's the total they took.
Yeah, I had that one down.
Okay.
Yeah.
So this one's slightly more difficult because
We'll move the x over.
Sure, you can use substitution. You can also use elimination here. So would you like to use substitution for this?
Yeah, I like substitution.
Okay. Actually, we should not do this because we want the number of adult tickets. And so we really should solve for x because that will leave us just the y.
Okay.
And that will be your answer when you finish here. So it's 5.6 times 168 minus y plus 9y equals right here. So you want to try solving that from here, please?
Oh, wait. And I got 89.
Yes, that is correct.
Okay. Yay. Okay. Let me see what else. Okay, let me find like one last thing to like maybe work on. Okay, I guess I can squeeze in like one of these because let's just try this. It's like, because I attempted this because I knew how to do some of them, but some of them I don't understand why it's not a function or like why it is.
Right. Well, so the first one, can you solve it for y?
I don't think so, no.
Okay, so that's just, yeah, let me snip it in here because it just looks odd the way it's written.
It just looks wonky, yeah.
And let me go through these. Okay, so let me share my screen. Okay, so the first one here, you can solve it for y. You move the 9. You move the 9 absolute value of x to the other side of the equation.
Okay.
So it ends up being y equals minus 9 absolute value of x plus 8. So this is good.
Okay. Yeah.
Okay. All right. Now the next one, these are really odd.
Well, I know y can't be an absolute value.
Yeah, so it's 36 minus x squared absolute value of y equals this. And there's two cases. There's y equals this and y equals the opposite x squared minus 36. So this, I believe, will be not a function because you can't solve it.
Right.
The next one looks odd, but if you solve for y,
which you can, yeah.
You can cross multiply here. And you get xy equals 2 divided by x. This is okay. Okay. And then the last one here, the 5x equals xy squared, it's kind of like the absolute value one. You can't have a y squared.
Well, you can have a y squared, yeah.
And you really can't have an absolute value of y.
Okay, yeah, that's correct.
Okay, so if you want to share your screen, we can see if we can get another one in.
One more,
Just
yeah.
maybe talk you through this next one. So the first one is a y minus 3 squared. So that is not
one, no.
Same with the next one there.
This one is.
That is, and then absolute value is not, absolute value of y is not a function.
It's not.
No.
Okay. Okay.
Let's see if we can get one more.
Mm.
So the cubed is okay. Cubed is okay.
But y squared is not.
Right. So that last one has a y squared in it. So you almost want to look for the ones that are, are out. That's y squared is out. Absolute value of y is also out.
Out, yeah. Then this one is.
That's okay.
Right. Okay, perfect. I think we can wrap it up here.
All right, let me just stop the recording real quick here. So on just a side note, I'm getting pretty busy. So if you need a time